Anyway, we're going to continue this afternoon's forum on finding and fixing with a real focus on the outcomes from a leakage sprint that was done at Northumbrian Water's Innovation Festival. Now, this festival went ahead despite COVID by going online like we're doing everything these days. And at the festival, Acquia ran a leakage sprint on driving rapid, cost-effective and efficient disruption-free repairs. And there were two particular approaches that were developed as a result of that. One was looking at micro excavation, which has come up a number of times in the previous session, and the other was exploring the potential for a DMA MOT to find leaks as part of routine checking and maintenance programs, similar to I guess the analogy is a car's MOT. So today's session will explain how these approaches were arrived at and the potential that we think they've got in terms of their future development. And Andrew Blenkinhart from Northumbrian Water will start the session setting out the design sprint process. So Andrew, you're very welcome. I'm hoping you're going to appear. There you are. Over to you.
Thank you very much, Peter. I'll just share. Okay, so hopefully we've got that on the screen there for everyone. So yeah, thank you very much. I'm Andrew Blenkan. I'm Network Performance Coordinator at Northumbrian Water. So I'm in the strategic planning team, and I'm also an innovation ambassador. So that's why I've been involved in the Innovation Festival last year as a sprint lead. Hopefully most of you have heard of the Innovation Festival. It's an annual event that we've been running since about 2017. And really the idea is to kind of step away from the day job, get into different surroundings, meet up with suppliers, customers and contractors, and really kind of think differently about how we can tackle some of our biggest challenges. So like you say, normally we would take over the Newcastle Racecourse and we would have a bit of a village of tents. We would have a main stage, there was a teepee for Pilates, there was a food tent so that everyone would stay fueled all throughout the day for all the activities. And the majority of it was kind of roundtable discussions, lots of flip charts. We would have the post-it notes, things up on the wall, everyone very, very much involved. But like everyone knows, a lot of the events this year, or all the events, have been affected by the pandemic. So we had to move into a virtual environment, and the majority of the work was on Zoom for the meetings, and we also use Miro as the virtual whiteboard. So we're able to do all the same things, but in a virtual environment. We also had a couple of other tools that we use there for kind of chat rooms and virtual meeting rooms and things like that. So we're still trying to kind of put on as wide a program as possible considering the circumstances. In terms of the numbers, we didn't get quite as many people as the previous year, but I think we certainly had more engagement from within the company, our own employees. We ended up having more organisations involved, more sponsors, and there was a huge increase in the number of countries that were able to take part. And also the number of water companies and universities. So even though we, went digital, that actually opened up a lot of avenues that we maybe hadn't expected. I just got a quick slide on here. I really like this one, which showed kind of the kind of global reach that we had with this event. I mean, it was quite incredible. We had some sprints were working kind of 24/7, where the teams were handing over morning and evening between different time zones. So like I say, I think moving to the digital kind of platform really broke down some barriers, and we were able to get people involved that we wouldn't otherwise have been able to do. So what do we get from this? Really, I mean, loads of ideas, as you can imagine. What we need to do now is to kind of pick out, I suppose, the best ones and look at what we're going to take forward. We've got kind of an innovation pot of money that we're kind of working from in Northumbrian Water, that we're trying to progress some of those ideas. And also we're looking at kind of the Ofwat Innovation Fund where we can utilise that. And with obviously having Acquia on board as well, how we can kind of utilise their research programmes as well. So it's about pulling it all together, looking at the best ideas and really trying to kind of drive the change within the business. Bringing it back to obviously we're at the Leakage conference and the relevance to leakage in this sprint. So I think Jez mentioned yesterday around the route map. So we've got the big questions for both zero leakage and zero interruptions, where quick and economic repairs form a fundamental part of the key outcomes. So we knew that this is like a key area to focus on. And again, I didn't know whether to give an introduction to the heat map, but I know Jeremy covered it again yesterday, and I don't want to go over too much ground, but it was good to see that obviously he highlighted the kind of less activity, I suppose, in the repairs box there. So we really felt this was a key area that we needed to understand a bit more and delve into. So that's why we had this as one of our key problem areas. So working with UK Weir as the sponsor for the sprint, we came up with a couple of mission statements and our aims. So we really wanted to look at how we can achieve increased repair speed and quality at a lower cost with less disruption to customers, communities, and the environment. And we also wanted to look at how we would mitigate the effect of an increasing number of leaks and burst repairs required to meet the ongoing commitments. So the reducing performance commitments, how are we going to make this step change? The overall aim was to identify the development opportunities to improve the effectiveness of repairs on the network, measured by cost reduction, disruption to supply, and the environment reduction, as well as time reduction. So that was kind of the overview, the highlight of the sprint. We managed to pull together a really good team of people. So overall, we had about 47 delegates registered to our sprint. And we had a really good cross-section across different areas. So we had the representatives from UK Weir. We had a lot of water companies. I think we must have had representatives from most of the water companies. So we had some really good expertise in the room. We also had a lot of suppliers and kind of the R&M contractors as well. So the people doing this work and providing the technology. And we had a couple of other utilities. We had some people from the gas network, and again, their insight was really valuable. Kind of the technologies and the techniques that they're already using, quite widespread in the gas industry. Kind of whether we can bring that across. And we had a couple of other people in there who I think just had a bit of interest. I thought it looked good, so they kind of joined in and. Just see what was going on really. So, like I say, we had about 47 people registered over the full week. But we had a core team of around 20, and these were the guys that were kind of really heavily involved day to day, making sure that we delivered something worthwhile at the end of the sprint. Just quickly give a little bit more information about the design sprint. So we follow the process that was developed by Google in around 2010, a guy called Jake Knapp, and there's really kind of 5 key areas that are supposed to be done over 5 days, or that was kind of the original concept. So we've got there the map, sketch, decide, prototype, and then test. And if I just go into the box below that, I'll explain a bit more how that kind of develops. So really the mapping is about understanding the problem and where you want to get to. So you're kind of looking at all the issues, all the problems that you face. And then it kind of goes through a voting exercise, and you're looking at what are the biggest issues, what are the biggest problems, so you can really focus on the ones that are going to have the biggest impact. So you kind of open it up with all the issues, then pull it back into the key ones. Then you go into the sketch phase, which is kind of coming up with the ideas. What can we do to resolve some of these issues? And again, this is about being as innovative as possible, coming up with as many ideas as you can, anything off the wall kind of, and then it goes through another scoring process where you look at, well, actually, which are the most likely, what's going to have the biggest impact, and you kind of bring that back down then into a kind of limited number of solutions, which you can then take to the next phase, which is the prototype. So then we're looking at kind of developing these solutions, really kind of building a business case. How would this work? What's possible? And then the final part of that is then kind of presenting back to the group. So that could be to customers to get their feedback and kind of validate the idea, but also kind of the peers. So we use kind of that wider team to run these ideas past and make sure we're on the right track. We just decided to make it a little bit more challenging for ourselves. We ended up trying to do this all in 3 days, so it was a very, very intense kind of experience, very hard work from everyone involved to try and rush through the process. And hopefully you'll see kind of some of the excellent work that was produced within such a short time frame. Just the final slide for me in terms of lessons learned. I touched on it there. 3 days isn't very long, so I just want to try and limit expectations to some extent. These are very big problems, very complex issues. Trying to solve them within a couple of days on a digital platform is difficult, but I think we made a good attempt, and maybe it's more kind of the ideas and what we need to do in the next stages of how we can kind of bring these new technologies into the water industry. In summary, the digital tools worked really well. We were really happy, say, with how the week went. Also, that kind of being able to bring in the global aspect, people that wouldn't normally have been able to attend, we've really opened it up, and I think we would look at that going forward, how we can include people in future events. But we didn't quite replicate the atmosphere. You know, there's nothing quite like being in the room with people and going around the tents and mixing and get that cross-pollination between sprints. We were very much kind of focused on what we needed to do and delivering our sprint. There's definitely lots to learn from other utilities. Like I say, we had some people from Cadent Gas who had some fantastic experience and really helped us drive some of the ideas forward. And I think, yeah, more of that would only be beneficial to what we can bring into our industry. Sorry, what networks? I don't think I need to explain to people on this call, but it is difficult. You know, these problems have been around for a long time, and people have been trying to solve it for a long time, and it's because it is difficult whenever you have to, you know, switch off the pipe, so you need to get something into the network. You know, that causes us lots of issues, and there's lots of problems. So there's a lot of that still to overcome, but hopefully, you know, I've seen some of the technology this afternoon on what we're looking at. It sounds like we're really starting to look at some new ideas. And then, yeah, just finally for me, a thank you to everyone that was involved, from Rebecca and the team at UK WEA, getting it involved and kind of getting everyone onto the sprint, to everyone that took part and kind of made the success of it that it was. And thank you all for listening. I think that's everything from my slides. So I will hand over to Rebecca to pick up the next part. Thank you.
If I just jump in just before you, thank you, Andrew. Appreciate that. Just to remind everybody, do put your questions in the chat, because right at the end we're going to have a kind of mop up of questions for all of the people who've been presenting. So don't be shy in coming forward. Put your questions in there in the chat, and we'll pick them up. So thanks very much, Andrew. And we're now going to hand over to Rebecca Haylock, who's the project manager for UKWEA. And as Andrew just said, she's going to really explain how the 3-day sprint participants shared their thinking and develop this sort of transformation roadmap. And I believe the presentation's going to keep us on our toes with some interactive elements, so I'm told, Rebecca. So over to you.
With a bit of luck, Peter, thank you very much. And thanks everyone for inviting me to speak today. Thank you, Andrew. That was a great introduction to the sprint. As Peter said, I'm Rebecca Haylock and I'm a consultant project manager for UKWEA. I work on a range of the zero leakage big question projects and also zero interruptions projects. And with Andrew and others, I was involved in organising and running the sprint back in September. So I'm going to talk to you about one aspect of the sprint that we developed over the 3 days, which was called a transformation map. And like Peter said, this is going to hopefully be interactive towards the end, where I'll try and gather some thoughts from you guys just in the chat. So over the course of the 3 days of the sprint, as you can imagine, even though it was remote, there was loads and loads of valuable discussion. The sprint itself was all around developing the 2 specific leakage repair solutions or concepts that Dennis and Mick are going to talk to you about in more detail later. But there was loads of wider areas discussed, as you can imagine, to capture and address the key sprint goal. How do we increase leakage repair speed and quality at lower costs with less disruption to customers, communities and the environment? And the sprint itself was all born out of the fact of, well, really of Jeremy Heath's heat map, where we saw that there was that large gap in that particular area of the heat map, and the sprint was really trying to progress and move forward in that particular area. So going back to all those insights that we captured on Miro, we had several breakout sessions where we looked at things like what are the factors affecting the challenge, what are the top priorities to tackle, mapping existing solutions and approaches. And obviously, as Andrew said, you know, we only had 3 days and we really had to drill down to 2 specific favourite sort of concepts that we wanted to develop. But loads of valuable discussion taken on board at the same time. So next slide, please, Andrew. Thanks. So in order to capture all this amazing content on our post-it notes on the Miro board, we developed what we called a transformation map. The idea being that we were going to capture what the discussion was and turn those into tangible actions that we needed to do over the next 5 years and beyond. So you can see the transformation map there on the right hand side with some of the post-it notes stuck on it. We decided to group those into themes. So the 6 themes you can see over on the left. So we thought that these were relevant themes to answering the sprint question. So 1, how do we ease the regulatory burden? Always a key question for whatever technology you're discussing. Incentivising the supply chain. What is the appetite for investment and funding? What is the R&D innovation around it, the systems and technology, and obviously what can we learn from other industries, and is there any cross-sector collaboration that we can work out? There was a lot of discussion around collaboration yesterday at the conference, so that's definitely a critical point. We also captured at the same time who we thought the key stakeholders we needed to engage and when, and who are at the moment the appropriate solution vendors and providers, looking also at, for example, the gas and oil industry. So all of this information that we then sort of tried to refine into tangible actions. So next slide, please, Andrew. Onto our transformation map, and I apologise the wording is small, but it was captured on a Miro board, but don't worry, I'm not expecting you to read it. I'm going to give you some key examples from each of those 6 key areas. If you want a copy of transformation map version 1, please feel free to email me. I'll put my email in the chat, and it'd be great to have some insight from you on that. So just giving you some key examples first. So under easing the regulatory burden, one of the areas we thought was critical was obviously the regulatory position, and we thought that it would be useful for us to work with Water UK to create an information note to clarify that regulatory position, to make it easier for innovators to enter the market. In terms of incentivising the supply chain, there's a lot of work that's been done by Water UK already in terms of incentivising the workforce via training qualifications. There's also work being done by Scottish Water at the moment around leak-free new networks and creating a national framework which also addresses that training and qualifications aspect, and Upware and Water UK have been working with them with that. In terms of appetite for investment, we had a great couple of people join us from Cadent Gas on the sprint with some really useful insight. In the gas industry, they have the Network Innovation Allowance, which is similar to our Ofwat fund. So one of the areas we thought we could follow how they do in the gas industry for our Ofwat funding. Moving on to the next 3, so bottom left, R&D and innovation. What are other technologies that are used in other industries, such as the gas industry? ULC Robotics have got their Syspot system. Can this be applied to the water industry? I know Thames Water are doing some work with that at the moment. Systems and technology. There's a lot of discussion around how we track existing deployed performance in a database of some sort and looking at new solutions. Could this be captured via, for example, the Leakage Hub and via the new National Failure Database that we're hoping to develop in the next few months. And then looking to cross-sector collaboration and learning from other industries. Some sectors, for example, gas, appear to be more advanced, and can we learn from them and collaborate now and identify and resolve past blockers? Okay, next slide, please, Andrew. Okay, so what we developed on the transformation map, there was a lot of what we could do. What we're kind of lacking is how we could do it and who we feel are the people that should be doing it. So I'm hoping to get some input from you in this next few minutes. I realise we haven't got much time, but we'll go with it anyway. So if you just think about that key sprint question that we had, how do we increase leakage repair speed and quality at lower cost with less disruption to customers, community and environment? And think about those 6 key theme areas: regulation, supply chain, investment, R&D, systems and technology, and cross-sector collaboration. What do you think are the key things that needs to be done in that area to move this forward? How would you do it? And who do you think is the person or group or body that should be leading it? Next slide, please, Andrew. Thanks. So over to you. Have a think about those 6 themes in the purple box there. And for each, just pick one of those themes perhaps that is of interest to you. Think about what the key activity you would carry out would be, how you would conduct that activity, and who do you feel that should be leading on that activity. If you put in the acronym for like regulation, just put reg and then answer the question what, how, who. I'll give you a few minutes to complete the exercise. I'm aware we've conscious we're running out of time anyway, but if this doesn't work, you can come and chat to us in the sessions afterwards in the leakage sprint fixing and repair solutions session, and we'd love to hear your thoughts on that. So if we just move on to the next slide, what I've got here while you have a think about it, thanks Andrew, is some more of the examples that came through on the transformation map. And feel free to look at these examples. These are more, like I say, of the what's. It would be great to understand a bit more of the hows and the who's, so we can really try and take some of these things forward. So I'll just talk through a couple more examples while hopefully, in fact, what I will also do is just post the sprint goal in the chat as well. There we go. So just to go through some other of these examples while you're having a think. Easing the regulatory burden. I think we all think that perhaps a more flexible Reg 31 to encourage innovation would be great, but how would we do this, and who is the right person to take the lead on that? In terms of incentivising the supply chain, one of the examples was, could we devise mechanisms to reward high quality quick repairs? Again, a great idea, but how could we do that, and who is the best person to take that forward? Some of the areas that are very research focused, obviously Upqueer could take forward, but there has to be other people that we could get to take some of these things forward. In terms of appetite for investment and funding, there's potential funds that we talked about during the sprint, from Department of Transport Street Works, Orca and RAIN. Orca's offshore robotics, RAIN is the nuclear industry. Is there funds we can leverage from those research organisations for technologies that would be applicable both in their industries and the water industry, for example? In terms of R&D and innovation, there was a lot of discussion around things that perhaps hadn't worked, but now with new innovation, maybe there is a solution that would work. Systems and technology. Is there systems and technology that support multiple repairs simultaneously? And cross-sector collaboration. Shared industry test beds. Andrea talked about the Centre of Excellence yesterday. We've got the Kempton rig with Thames Water. Potentially there's lots of information that could be gleaned from that. So a couple of notes already in the chat, so thank you for that, and I'm conscious that I'm going to run out of time. So if you want to continue posting in the chat whilst also listening to Mick and Dennis, that would be really helpful, and perhaps we could pick up on some of those at the end. Peter, would that be okay?
Yeah, we'll do that.
Great. So next slide, Andrew. And just before I do that, Joe's made a really good point around regulation. Talk to the highways authorities and government regarding access to roads and rewards for speedy repairs. That's a really good idea. Thank you, Joe. And Mikhail said, is there a role for future water in supply chain? Another good point. Thank you. This is really helpful. So any other ideas like that, if you want to post them in the chat, that would really help me take this transformation map forward. So just to summarise, the transformation map was developed just during that 3-day sprint and now really needs moving forward, mindful of the barriers to implementation and how these can be overcome. There's lots of learning from potentially from the gas industry, etc. And we must encourage and be open to wider cross-sector collaboration. Please email me. I'll put my email in the chat if you'd like a copy of the transformation map and would like to input further. And thanks ever so much for your time.
Thanks very much indeed, Rebecca. So when we get to the end, we'll come straight to you and we'll go back to the questions that you posed and give you a chance to pick up some of the feedback. And thank you so much for that transformation map. It's reminded me I must go to Specsavers as soon as I'm actually able to. I couldn't get anywhere close to seeing that, but I'll get your email address and get hold of a copy.
Thank you.
Thanks a lot. A lot of food for thought there. As I say, we'll come back to that. It's now time to introduce Dennis Dello, though I don't think I probably need to introduce him because I think we all recognise Dennis's face there. And you're the technical lead for Leakage at Upqueer now, Dennis. And we all know you, and you've been involved with this network and conference for, I think, well over 20 years before you retired, and it's great to see you still involved with it. Now you're going to set out the sprint's findings on micro excavation and leakage location, I believe. So I'll hand over to you, Dennis.
Thanks, Peter. And yes, it's very nice to be still involved with this conference that I started 21 years ago. So yes, in the sprint sessions, we worked on two concepts over what was effectively a couple of days. And I'm going to tell you about one of those, and then Mick will tell you about the other one. So in our sprint, we looked at micro-excavation and the concept of carrying out a leak repair within a micro-excavation. If we're going to achieve significantly lower levels of leakage in the coming years, we're going to have to find and repair a lot of small leaks. But the problem with small leaks is that the cost of the repair can be a lot more than the value of the water we save. So we're going to have to find ways of making repair of small leaks more economic. So our proposition was to develop a way to repair a leak, leaving the smallest possible footprint, especially for a small leak, at the lowest possible cost and with minimum disruption, using micro-excavation techniques and then keyhole leak repairs within the micro-excavation. Next slide, please. So we were aiming to reduce costs and increase productivity, also to reduce interruptions to supply by carrying out the repairs more quickly, to reduce the area of work, to minimize disruption to road users, and overall to improve the customer experience. Next slide, please. So overall, the process consists of 4 stages: location, excavation, repair, and reinstatement. And in 2 of those, the areas, the ones in black, excavation and reinstatement, we already have fairly well established tools and techniques for carrying out those. The other 2, location and repair, are the 2 where we do need further research and development. In location, if we're going to carry out the repair within a micro excavation, we clearly have to pinpoint the leak much more accurately than we would normally have to if we were going to have a conventional repair with a conventional excavation. So for micro excavation repairs, we'd need to other methods of repair, of pinpointing the leak very accurately indeed. And then on the repair, we want to be able to do the repair down the hole within the micro excavation, doing all the work from the surface, which is currently not possible. So we need new tools and techniques for doing that. Next slide, please, Andrew. So this is the kind of wonderful artwork you get out of these sprints. This kind of goes through the process that we came up with, starting with the top left-hand corner. Locating the leak, therefore, it has to be a 2-stage process. So firstly, we'll carry out a conventional leak location using a correlator, probably between a couple of hydrants, and get an approximate location for the leak. But then to pinpoint it, we've got several ideas as to how we might be able to do that, and this is one of them. In this case, what we've done is inserted 2 metallic rods vertically from the surface until they're in contact with the pipe, bracketing the leak, so one on each side of the leak, so they might be, say, 5 meters apart. And then we use these as additional acoustic sensing points with a correlator, and hopefully this will allow us to pinpoint the precise location of the leak much more accurately. Then when we've done that, then we'll make the micro excavation using a conventional coring machine, remove the soil using an air lance and a vacuum excavator, and then down in the bottom left-hand corner, we need some way of fixing the repair clamp from the surface, lowering it into the ground, closing it around the pipe and tightening the bolts from the surface, doing all the work from the surface within the micro excavation. We then backfill the hole and then replace the core and reinstate in the normal way. Next slide, please. So here are a few pictures of what some stages of that would look like. This is a conventional coring machine that will do the micro excavation, typically making a cylindrical, probably 300 millimeter diameter hole. Next slide. And then we remove the soil using an air lance and a vacuum excavator in the normal way. Next slide. And then we repair the leak down the hole, and this is the part that needs development. We need to develop some system using long-handled tools that will allow us to carry out the repair within the micro-excavation, working from the surface. Next slide, please. Then we'll replace the soil in the excavation, compacting it as we go. And then next slide. And lastly, we replace the core and complete the reinstatement in the normal way. Next slide. So a couple of options we consider for the repair itself. Ideally, we would try to develop some system of long-handled tools that will allow us to carry out the repair using a conventional repair clamp, like the one in the picture. That's a typical repair clamp for a small diameter, 100, 150 mil diameter pipe. And we'd have to fix that from the surface and tighten up the bolts from the surface. Now, if we find we can't do that, then we might have to design a modified repair clamp and some special tools designed specifically to work with the modified clamp to do the repair within a micro excavation. Next slide, please. So to look into these areas where we know we need some further research and development, we've got several Acquia projects either about to start or in the pipeline. This first one is one that Jez mentioned very briefly yesterday, transferring minimal excavation methods into the water industry. We know that micro excavation methods are already used by the UK gas industry for certain applications, and also by some water utilities in other countries. But there's very little use of these techniques currently in the UK water industry. So this project will look at methods used in other utilities and in other countries, and identify the issues and the barriers preventing the use of these techniques within the UK water industry. If we find that we need to develop some new tools and techniques, which almost certainly we will have to, then the project will develop a functional specification, which we will then use to facilitate application for innovation funding to develop these. So the project's about to start. We've received a number of expressions of interest, and it should go out to tender in the next few weeks. Next slide, please, Andrew. On the area of precise leak location, we have a couple of PhD projects which are about to start at Southampton University. The first one is the one I mentioned earlier, using insertion rods inserted vertically along the pipe, in contact with the pipe, but obviously being very careful not to puncture the pipe, within a few meters of the leak, and then using those insertion rods as additional access points, additional acoustic sounding points for correlation, which we think should allow for more accurate location of the leak. This project is about to start. It's agreed and will start at Southampton in September of this year. It will actually look at a wider area. We're also looking at it using these insertion rods to give us more frequent acoustic access points on trunk mains and a few other applications, but we will particularly look at it as an application in this case of accurate pinpointing of leak to use with micro excavation. And then another idea is to look at possibly using multi-sensor arrays laid out on the ground surface along the pipe, using various types of sensors like geophones and laser vibrometers to pick up the signals from the leak, acoustic and vibrational signals from the leak from a number of locations along the line of the pipe. And then we'll need to develop new analysis methods for use with synchronized ground vibration measurements. We're still to agree the start of this project, but again, we hope that we'll have it up and running, ready in time to start at Southampton in September this year. And that's my lot. Thank you.
Fantastic, Dennis. Thank you as always. And just to remind everybody, Rebecca's challenge is still very much there. It's dried up a bit, Rebecca, I've noticed, as people have got enthralled with Dennis. But as you've got a few minutes, do keep going back to Rebecca's challenge. Thank you very much indeed, Dennis. I've got one or two questions for you myself before we get at the end. So we're now going to hand over to Mick Baker, the Tactical Planning Manager at Northumbrian Water, who's going to bring us the findings of the second concept within the sprint, letting the fix find the leak, the potential of the DMA MOT. This particularly addresses the increasing difficulty in finding those smaller and ever smaller leaks and the associated cost of repairing them that Dennis sort of brought out. And it's something that we all need to kind of address as we drive towards meeting those ever tighter leakage reduction targets, which is really exercising, I know, many of our leakage teams. So over to you, Mick.
Thanks, Peter. Good afternoon, everybody. The next presentation is going to cover the second leakage sprint team, called myself the Squirts. This group were asked to explore the opportunities that emerging gel repair technology could present the UK water industry as we look to tackle our leakage challenge. First slide, please, Andrew. So what's the issue we're trying to address? Well, the first key point is the cost to business, customers and the environment as we look to drive leakage down. It's the cost to find the leaks in the first place, be that with new technologies such as multi-deployment of noise logger correlators to more active leakage activity within the networks. The big mains are the easy ones, we're good at finding them and repairing them. The leakage benefit versus the cost to repair makes this a cost-effective leakage activity in the round. However, as we look for those smaller and smaller leaks in our network in order to meet our leakage commitments, then this task becomes harder and the costs are likely to become actually unsustainable for the industry and our customers. The Squirts thought this was an area that the new gel and plug technologies could offer us a real cost-beneficial solution to reduce this type of leakage. Why can we not just repair everything in one go regardless of the leak location or the size? So the Squirts propose find and fix version 2, which is around replacing the traditional find and fix activity by just letting the pipe repair find and fix the leak. So if we consider that in a little more detail, why the industry actually needs to change that current find and fix approach now. So the first point is really around affordability for customers. Customers and our regulators want us to provide a great service, but at an affordable cost. So we must become more efficient in how we deliver that service. We have some very stretching leakage targets. It's fair to say that this is starting to really push the boundaries that we as an industry can deliver. And that's a good thing, as at times like this, when we're being pushed out of our comfort zones, that we become more receptive to doing things differently. The cost to find and fix of smaller and smaller leaks using our traditional approach is going to become uneconomical. Costs to repair leaks are also increasing with the introduction by local authorities of highway permits, etc. The truth is we just can't afford to repair all the leaks we need to hit our future leakage aspirations. It's going to be unaffordable and too disruptive unless we do something different. So we think the Squirts thought we were actually reaching the limit of our traditional approach to find and fix. And we actually need to move on to a new approach to complement this and to take us up to the next level. Technologies are out there that will help us on that journey, but many are still in development or in an early stage of rollout. And the idea of a little robot running through the pipes, fixing the leaks as they go is a great one, and probably one day will become reality, but what do we do in the meantime? So the Squirts said what we need to do is actually look for more options within our leakage toolbox, even if it's something that's just going to buy us a bit of time. Innovation will be the key to helping us achieve our goals. Next slide, please, Andrew. A bit of lag there. So we came up with a concept of a DMA MOT, so which is a regular health check and service, much like we do with our cars, but let's apply that principle to our DMAs. So we're talking about the advanced servicing of our mains within the DMAs using pig and gel technologies. So it's an in-pipe solution. It's aimed at reducing our leakage within DMAs with no need to go looking for it, and certainly no need to keep digging up the roads to fix it. It's like the old way of fixing your leaking car radiator by putting the egg white into it. It's the same principle, but using self-sealing gels that are now coming onto the market and delivering them to the source of the leakage as an internal repair plug. So the group believe that gel plugs could deliver that as a new concept of the DMA MOT, and the benefits we think would be quite significant. We think we would say lower costs and disruption to customers and the public, about fixing smaller and smaller leaks in a more cost-effective way without digging up the streets. It defers the need for full-scale network replacement, so it buys us some time. It offers potential to start addressing background leakage, which is the real tricky one, including potentially customer-side leakage. And it also allows us to start looking at the natural rate of rise within the leakage of leakage in the DMA, which then can be controlled through sensors until a more long-lasting pipe replacement systems have been developed. So all this can be part of your service in your DMA, so we deliver better leakage management, your find and fix activity, periodic reduction in low-level background leakage. But also don't forget about the water quality benefits as well. So incorporate it with boundary valve management, your mains flushing, all aimed at reducing your appearance contacts, your taste contacts, etc. So it's about monitoring your assets' condition and the performance so that when the time's right, we can service the DMA and maximize the life and performance of the asset. This approach will mean we need to consider the way we design and install our water distribution networks and DMAs going forward, as this ensures our ability to insert and remove gel plugs can be considered as business as usual. So there are barriers that we need to overcome to achieve success. The squirts had the ideas, but we haven't got all the answers, but together we think the industry can overcome them. First one we wanted to point out was the ever-stretching regulatory performance challenges. But this journey that we're on will not just need to involve the water industry, but all those who regulate us as well. Innovation brings opportunity, but this will require us all to think differently. And we've got a couple of examples there. So the 3-hour interruptions is a common industry performance measure, but that could potentially stop innovation dead in its tracks. So new products may offer the customers better levels of service within an affordable bill, but maintaining compliance to some of the common measures does prove challenging. So IDS is a great measure when it comes to a pipe burst because it ensures we get the focus on getting customers' water back on as soon as we can. But for planned activities such as this, do we need some regulatory relaxation that's going to enable us to deliver this type of activity safely and effectively for our people, our contractors and our customers? Challenge out there for water quality compliance and new products against the regulatory quality framework. That presents a challenge. We must always ensure the product's safe to use to supply safe water to customers. But could we have a fast track approach for some of the lower risk products that maybe are already in use in water networks elsewhere? And sometimes these are even in use within Europe itself. We need to always remember the customers are at the heart of this, and we need to be making sure we engage with them so they feel part of what the industry is trying to achieve. There will be some concern, I would imagine, about putting things like gel plugs into the water pipes. So we need a joint approach to across all the sectors to allay any fears and concerns. And finally, we do need to encourage and incentivize through the open market. The supply chain nearly always rises to the challenge if they think it's viable for them to invest in the R&D of the products. We only have a few players in this market, so we need to both support them and encourage others to join us. Last slide, please, Andrew. So within the BQ and BQ3 teams, we're now exploring how we move the sprint concept forward. We've opened up discussions with suppliers and we've started to develop a roadmap of activity that's going to start allowing us to develop this MOT concept to become reality. It's clear to those involved that this will require close collaboration, not just with UCWIA, but within the water companies, the regulators, suppliers. There are UCWIA research initiatives already planned, such as the benefits to be gained from the use of novel pipeliners. So we can explore the opportunities that they present in supporting the DMA concept. So to conclude, the Squirts believe that properly managed, the concept of a regular DMA MOT using technology like gel plugs could deliver the industry a cost beneficial solution to tackle those smaller and smaller leaks we need to find in a more cost-effective and environmentally acceptable way. So we need to move away from open disruptive excavations on our streets to a silent street works approach. And that's going to be for the benefit of all current and future generations of customers. Thanks. Thank you, Anne. That's me done.
Thanks very much indeed, Mick. We'll go to some general questions in a minute. I have to say we've got a whole new language going on here, haven't we? So you've got your squirts, we've got pig and gel. I mean, we've got the lot here. And your egg white in the radiator took me back to a really embarrassing moment on the A1 in a Mini 40 odd years ago, but we won't go into that one either. Anyway, let's go back to Rebecca. You set a bit of a challenge earlier on. Let's give you a few minutes just to reflect on that, and then we'll open up some more general questions. And if anybody wants to put any other questions in, please do go ahead. But over to you, Rebecca.
Thank you, Peter. So thanks everyone who's posted in the chat. Like I say, we've got a session straight after this, so feel free to come and talk to us about it in more detail. I think the transformation map's very much the what, and it's the how and the who that's going to take it forward. So thanks for your suggestions, and I need to go back now and really drill down as to how these things are going to progress. But suggestions that have come through, I've already talked about Joe's suggestion regarding the Highways Authority, Michael about future water, that's great. Stuart Maudit talked about start actively QAing work and requiring a fix to be signed off by the local leakage manager prior to reinstatement. Yeah, good. So who would take that forward? That was for supply chain. I suppose a group with the leakage managers, I guess. This is the thing, isn't it? They're all great ideas, but it's actually progressing them forward. Alan Cunningham has said, yeah, a good point as well. Make it easier to progress this for supply chain from a successful technology trial to a full adoption. We did talk about this on the sprint, actually, the fact that there is this pause, and he's saying how to avoid the pause and then full tender process that tends to take place and replace with a gradual phased rollout. Good point. And who he was saying the water companies. And then Steve Toombs, who was kindly one of our sprinters on back in September, so thanks Steve, was talking about the R&D aspects and dead ends again, and perhaps it was you that raised this at the sprint itself, Steve. Use historic reports from water and gas industry, old research organisations, WRC and the equivalent in gas. Mining, this could be an UPQueer project. Oh, I love a good project like that. That's the right detective project, isn't it? Or through the Ofwat Innovation Fund. Yeah, that's a good idea. Thanks, Steve. And Michael has talked about the Pipe Industries Guild. Yeah, have a lot of supply chain members. They may also have a view on how the supply chain can be better incentivised. That's a really good point. Thank you very much. And I think the rest of those comments were for Dennis and for Mick. So thank you ever so much for that input so far. Like I say, we'll be in the sessions group later. So any other information valuably received, and please feel free to drop me an email if you want to talk about it further. And if you can't read it, Peter, you can email me and I will send you a copy as well.
Thanks very much indeed, Rebecca. Well, as a link in there to Dennis, perhaps we'll pick up with that one. Dennis, there's a question in here, thinking back to the Aqua Tight repair clamp. You wouldn't have to tighten the repair clamp around the leak repair as the resin would form the seal around the pipe. Would it make it easier to do what you were suggesting in your pictures, working from the top? Have you given that any thought?
Yes, in fact, I gave that some thought when Jez and Mike from MW were talking about it. I think that's a really interesting idea and really worth exploring. So we will talk to Jez and Mike at MW once we get this project going.
And another point just coming from Joe, actually, which kind of goes back to some of the challenge you've set, Rebecca, which is about the commercial models that exist around here. I know that came up in the map that you were talking about earlier. Margins are very, very tight, but has there been any thought, Rebecca, about the sort of different commercial models that might help incentivize the supply chain to want to get involved in this rather than being rewarded for dry holes sometimes?
Yeah, no, it is a really good point, and sorry, it's something we need to consider. So thanks for that, Joe.
Quite often, there's been quite a discussion about Cadent Gas. I mean, Andrew, you raised it right at the beginning, talking about Cadent Gas and learning. I was just interested whether there was any learning going back the other way, because these sort of things work pretty well. People will turn up, and organisations will turn up to the Innovation Festival, but they're not doing it just because they want to come and help the water industry. They're doing it because they want to learn something too. Is it genuinely a two-way thing?
I'm not sure how much I took away from it in terms of technology and things we're doing, but hopefully kind of some of the relationships they built kind of within the sprint, both in terms of the participants within our sprint, but like I say, there was kind of a wider kind of gathering on the overall Innovation Festival. So I think, yeah, building those relationships with the local companies. Sometimes there's these kind of links that you don't realize are there, and this kind of bringing all these different people together, they can suddenly realize that someone doing something with a technology or communicating device can bring benefits to somewhere that they hadn't thought of before. So I think it definitely brings those people together to realize kind of something or relationship that they wouldn't have expected.
Just before letting you complete off the hook, the other thought that I had, just in terms of this whole conversation, is about how do we build confidence in our ability to go out there and innovate and experiment and then implement things. So I guess one of the killer questions is, have you got some examples of some success stories from the previous festivals? Because they've been running for a while now.
Yeah, we've got a couple of good ones. Leakage specific. We had one with PA Consulting in the first festival, where we developed like a DMA categorization algorithm, which was to look at kind of the flow patterns of DMAs and the different kind of techniques that would work best for kind of leakage reduction, or what they've responded to best in the past. We also kind of looked at a layer in GIS where we used our pipe information and historic burst data to try and identify some of the kind of the hotspots within an area, the most likely areas to leak. And I think that was something that was highlighted yesterday, with some of the models now probably going to the next stage of that and getting into some kind of machine learning and really intelligent stuff. I was using historic data to highlight those areas. And I think outside of leakage, the other key one that we've had, which we're proud of, is the National Underground Infrastructure Map. So I believe that one's kind of nationwide, that's really taken off, and trying to develop these kind of underground maps for all utilities kind of across the country. So I believe that one's been really successful and really progressing now.
Thank you. And Mick, you were talking about the going back to the gel plugs. I got the impression from how you were talking that you were talking about smaller diameter pipes. So to what extent can we use these on larger trunk main?
It's a really good question, Peter. And I think the answer is that I'm not 100% sure at the moment, to be honest. I think the focus was particularly on the distribution network. So if we imagine if we inject a plug of this gel into the pipe, and it's got to be carried through on a water stream, it's the ability for it to contact the pipe wall. So obviously the bigger the pipe, the more gel plug you have to insert into that pipe. So whether the practicalities of that work or not, I think that's something we need to work with the suppliers to look at that, I think. But certainly on the distribution networks, the smaller pipes, I think it's used quite successfully in other countries. I think Israel, I think, is a good example where they developed this sort of technology. And I think it's a challenge, because I think one of the biggest challenges is an assumption that trunk mains don't leak. And I think we all know they do. So could we adapt that technology and use it on trunk mains, similar to what we do for the ice pigging? Ice pigging came along a few years ago. That was a new concept. So it's about getting the gel effectively onto the pipe wall rather than getting it carried through on the water stream in the main. So I think the larger the pipe, I think it will present challenges. Yeah.
The other thing that struck me in what you were saying was the customer impact, and we're sort of setting an expectation in the water industry with customers about you not being off water supply for long periods of time. And have you got any perspectives about how we position this with customers by saying we want to do some planned work, but it is going to result with you going off water?
I mean, I can only refer back to the work we did with the customers in Northumbrian Water as part of PR19 engagement, in terms, because I was involved in the resilience, and I can only speak for Northumbrian Water and Essex and Suffolk Water customers, but most of them were quite receptive actually to accepting that at times we've got to go into our networks and repair them, and at times they're going to lose the supply. I think what they said was engage with them, communicate well with them, and keep them informed. They were the key things. So I think it's probably something that we as an industry maybe need to start asking our customers if we can start identifying more cost-effective ways of effectively keeping the bills low as we can possibly get them, and sharing that burden across different generations. Are they receptive to that? So I think it's worth the industry asking them the question, actually, because then it helps us have that discussion with the regulator to say, I think, as I said in my slides, if a pipe bursts, respond quick, get it fixed, get the water back on, that's fine. But actually, is this new technology almost failing at the first hurdle because we cannot actually isolate the pipe, apply this repair technique or rehabilitation technique to the pipe in the timescales we've got. So I think it's a one for everybody, customers, the industry, and the regulator, I think, to look at that.
I was intrigued. I think a number of you made reference to the sort of regulatory approvals, and Reg 31, I think, was referenced particularly. I'm not sure if that was the only sort of regulatory approval that was being sought or was being seen as a barrier. And then I think it might have been Andrew's presentation, was talking about the fact that in the gas industry that they seem to be able to get regulatory approvals more quickly. Does anybody want to sort of comment on that?
I think that was on the transformation map. That was interesting because that comment did come from Cadent Gas, but I have to be honest, when I then drilled down to try and get a bit further information, it was, we need to do a bit more digging on that, because it would be great to understand how they managed to do it. When we did the sprint, I couldn't quite gather that information though, unfortunately.
Well, we mustn't allow it to be a barrier to innovation.
Pardon?
We must allow that to be a barrier to innovation. Somehow we have to get past those problems.
Yeah, absolutely. As you're talking, Dennis, the other thing that occurred to me, just going back to micro excavations for a minute, was there's lots of ways to make that business case, and you touched on quite a few of them as you were talking. But just interested in whether you've got any particular perspectives about the fact that it might has a potential to encourage other people into the industry, particularly in something which hasn't necessarily always been seen as a terribly attractive part to get into. How we might move from manual, in inverted commas, labour into more technical jobs on the front line.
Yeah, people like to feel that they're good at what they're doing, don't they? So if we can make a job more interesting, more technically challenging, more rewarding, something that gives them better feedback from the customers, people are going to find the job more rewarding. So,
yes, I was also thinking about the fact that we probably got fewer and fewer people to do, construction type front end jobs, whatever they might be, and therefore we need to be pulling from a much broader labour pool than we've historically been able to.
Yeah. Large parts of our labour force are people who've been in the industry for a very long time, and often their fathers and grandfathers as well. Yes, so perhaps we need to get away from that a bit and bring in people from other areas and encourage training, vocational training that leads people into this kind of area of industry and makes it rewarding.
The question I said I was going to ask you, because I might appear a little bit dense here, but I didn't quite get in your presentation the insertion rods. I don't know if you could just give me a quick 30-second teaching on what exactly they were.
Well, we haven't developed them yet, but it's a very, very basic concept. It's as simple as it sounds, that you insert an insertion rod vertically, either by driving it into the ground, or perhaps by screwing it into the ground, or perhaps by drilling a very narrow diameter hole and then inserting the rod in the hole. The difficult part would be getting it down to the pipe. If it's going to be used as an acoustic sensing point, it almost certainly needs to be in contact with the pipe. So that's the dangerous bit, making firm contact with the pipe without actually puncturing the pipe. But yes, it's as simple as that. That gives us a metallic rod that's in direct contact with the pipe, which will allow us to do a much better acoustic correlation of the leak position than we would by sensing from the surface with a geophone and relying on transmission of the sound through the soil. We'll get much better transmission of the sound through a metallic rod. The project that we want to do at Southampton on that is actually born out of a desire to find something to help us on trunk mains, because one of the problems with leak detection on trunk mains is that we're having usually to correlate over very large distances, because the number of access points to trunk mains for acoustic sensing are very few and far between. So that was the idea of this, to give us some more intermediate access points. So these things will be inserted and left permanently to use for trunk main leak detection. But having done that, when we came to this micro excavation problem, we thought, could we also use that idea on a much more localized way to get a very accurate localized leak location?
Really good point. Thank you, Dave. That's helped my knowledge no end. I have to say, being a mean CEO, I'm always asking, can we, given we're rolling out lots and lots of hydrophones and we're putting in smart meters all over the place, how can we better use the intelligence to pinpoint leaks before we start spending any more money? But that's just because I'm horrible and unreasonable. But there's definitely a big data opportunity in that, I'm sure. And perhaps I'll just finish before I do a quick close. I'll go back to Andrew just to give a plug for the Innovation Festival and maybe what's planned for 2021.
Well, yeah, I'm not really sure at the moment. Obviously, we don't really know how things are going to develop through this year. So, like I mentioned, going to the digital platform certainly kind of took down barriers that we were able to kind of reach people that we haven't been able to before, kind of across continents and things like that. So I think what we were considering was maybe a hybrid version, because let's say we want to get that balance of having your festival atmosphere and people together, but then being able to kind of bring people in on the digital platforms to partake in that as well. So I think we were leaning towards a kind of hybrid festival anyway. It might be fully digital again this year. Yeah, we'll just have to see how it goes. But there will certainly be a digital element to make sure we get as many people involved as we can.
I think we might be thinking of hybrid leakage conferences in the future as well.
I think they work really well, certainly in terms of the getting a lot more people involved. And the point that was made earlier on about the Innovation Festival attracting lots of people from lots of different countries is a great one, because that immediately gives a much broader reach, doesn't it? So hybrid is probably where we're going to be going, isn't it? Anyway, I'd like to thank all of you for some brilliant and really thought-provoking presentations. Thank you so much for that. And if you've got any further questions, much as Rebecca was saying, you're invited to join the speakers after 4:30 onwards in the Leakage Sprint follow-up. So please, if you do want to carry on the conversation, that's how to do it. And a big thank you to everyone who shared their projects, not just in this session, but actually throughout the 2 days, and to everyone who's contributed to the chat and taken part in all of the networking. And of course, to the conference sponsors and supporters for their continued support. And I have to give a big thank you to Aquasuite, Burmad, Guterman, HWM, Muller, Avero, SME Water, Takura, Technolog, and of course to our media partner, The Water Report, and bless her, Karma. Over the last few days, you've seen exactly the kind of knowledge sharing and collaboration that's going to be so vital as we move forward to meet our public interest commitment goals, and that we look forward to unlocking the opportunities presented by the Ofwat Innovation Fund. Collaboration, innovation and behavioural change are going to be absolutely key to unlocking the challenges posed for us in terms of leakage, avoiding duplicating effort, sharing our learning and maximising the value, and thinking differently about repair techniques to minimise carbon, drive the right outcomes and support the health and well-being of our people is all going to be pretty important stuff. So let's keep pushing on the doors. The past couple of days have opened, and let's really push ourselves to keep innovating, keep collaborating, keep thinking differently. And on the subject of collaboration, I hope you'll just let me make a small plug at this point for Innovate East, which is our joint collaboration with Essex and Suffolk Water, so Anglian and Essex and Suffolk, and obviously Essex and Suffolk is part of Northumbrian. And that's we're about to kick off a year, in fact, of virtual innovation activity through Innovate East at the end of March. And this is focused around routes to net zero with work streams on technology-led, nature-led routes, and a third work stream looking at how we unlock the potential of hydrogen. So please do get involved with that. And the easiest way to find out more is to visit the dedicated Innovate East page on LinkedIn if you're interested in that. So a bit of a shameless plug, I'm afraid, but that's the nature of the beast. I want to thank you all very much indeed for being involved, and I think I would like to thank, last and not least, Judith, for so excellently preparing today's and yesterday's event, and for marshalling certainly those who've chaired and presented so expertly. So Judith, thank you very much indeed. And I know at this point I'd normally say have a very safe trip home, but of course that's one advantage of doing these things virtually. I don't have to say that. So there are benefits from lockdown. So thanks very much for paying attention and being involved.